Hey, this is Mr. Drogemeyer. Thanks for joining me for our Algebra 1 lesson videos. Today we are in Unit 7, looking at lessons 6 and 7 using linear inequalities. And so we've been talking about how we set up linear inequalities, how we solve them. In this particular lesson, we're looking at how we can apply them in real situations. So we'll just jump into this first problem. It says that it usually takes Jake 30 minutes driving at 52 miles per hour to go from home to work. But today he has to take a detour. It's going to make his trip 10 miles longer than usual. So what's the minimum speed that he should travel so that he can reach that destination in less than 40 minutes? All right, well, this is kind of your basic distance is equal to rate times time problem. If we look at his normal information there, we would find that distance by taking his rate, which is 52 miles per hour, times his time. And since his time's in minutes, we need to change that to hours. Well, there are 30 minutes, or there are 60 minutes in an hour, so 30 minutes is 1/2 of an hour. And so his normal distance that he's traveling, 52 times a half, is 26 miles. In this case, he's going to have to go an extra 10 miles. So in our situation here, we're going to know the distance, which is 36 miles. We don't know the rate. That's what we're trying to find. And the time, we want it to be less than 40 minutes. Well, 40 minutes is 2/3 of an hour, 40 over 60. So our time here is 2/3. We're trying to figure out what this rate is. All right, so let's set this up as an inequality. And so in this case, we know that we want his time to be less than that 40 minutes. We want it to be less than 2/3. So if we have the time isolated over here, time is going to be the same as the distance divided by the rate. Well, we know that our distance is 36. We're trying to find that rate. So if we're solving this for r, I need to multiply each side by r to get it out of that denominator. So I get 36 is less than 2/3 r. And then to solve for r, I'm going to have to divide each side by 2/3. Well, dividing by 2/3 is the same as multiplying by 3/2. Dividing by a fraction is the same as multiplying by its reciprocal. So we're multiplying each side by 3/2. And so 3/2 times 36 is going to be 59. Excuse me, I had a problem there. It's 54, not 59. So 3/2 times 36 is 54. And so we get 54 less than r because the 2/3 times 3/2 is 1. And remember, if we want to flip this around to where the r is on this side, we also flip that symbol. So we would say that his speed needs to be greater than 54, and this was in miles per hour. All right, let's take a look at our second example here. It says Leonard is timing how fast he can do a series of 10 math questions. He's aiming to do them in less than 30 minutes. He's already done 4 questions, with each of them taking 4 minutes to complete. So on average, how much time does Leonard have on each remaining question so he can reach his goal? All right, so if he's done 4 questions already and each one has taken 4 minutes, 4 times 4 means that he's already used 16 minutes and he has 6 questions remaining because he was doing 10 total. Oops. 6 questions remaining. All right, so when we go to set this up, he wants to be done in less than 30 minutes. He has 14 minutes left. So his time needs to be less than 14. Well, right now he has 6 questions left, and we want to know how many seconds. I'm going to use T to represent our time here, or excuse me, how many minutes he can spend on each question. So 6 times the number of minutes has to be less than 14. We divide each side by 6. And we would get, let's see, that would be 2 2/6, or 2 2/3 minutes per question is what he would have left. So 14/6, that simplifies to 7/3, and 7/3 as a mixed number would be 2 1/3. So since he was spending 4 minutes a question on those first 4, he only has 2 1/3 minutes per question on the remaining. All right, and then our last one here says a retail store is buying a 300 count for a device and another 150 count for another version of the same device that costs $150 less. So 300 of the original and then 150 of the new, and then that new one is $150 less. All right, they want to know what's the maximum cost of the original device given that the store did not go over the budget of $135,000. All right, so our original device, we'll call it X. We know that they bought 300 of those. So 300 times whatever cost for this original device. And then they also bought 150 of the new device, and we know that it costs 150 less than the original. So X is our cost for the original. X minus 150 is going to give us the cost for the new one. And we know that this total did not go over that 135,000. So it was less than or equal to 135,000. And so now we can start to solve this inequality for X. So I'm going to start by distributing that 150. So I still have my 300x here. 150 times x is 150x. And then if we take 150 times a negative 150, we'd get negative 22,500. That's less than or equal to the 135,000 total. Now we're going to combine like terms. 300x and 150x is 450x. I'm going to add that 22,500 to each side, which clears it from this side. And 22,500 plus the 135,000 gives me 157,500. And so my last step would be to divide each side by 450. And I'm going to grab my calculator back up here. So 157,500 divided by 450. And that tells me that the cost of the original cannot be more than $350. So that's our original. And that would mean that the additional or the other device, the most it could be would be $200. So, all right, that's all I've got for you for this one. Appreciate you taking the time to watch. As always, if you have questions, please let us know. Thanks. Have a great day.